Development boards typically come with male header pins like this. The expectation is that you're going to mount them pointing down in these boards. So they can straddle a breadboard like this, and you can get access to pins on both sides. That's not going to work very well with larger dev boards like this because you just won't have the room to get to the sides. So it's going to be tempting to try something like, oh, I don't know, maybe have it go off the side. We can connect it with something else, either from the bottom, or if we're going to solder it, well, maybe we could just use the same stuff on the top. No, never do this. This is just an accident waiting to happen. Something will drop, short your stuff out, and ruin your circuits. A basic rule in electronics is that the male exposed conductors are connected to passive, things that sink power, and the female sockets are connected to power sources for safety. You wouldn't do something like this. It's actually illegal. It's dangerous, and the same logic applies to our electronic circuits. Instead, we're going to use female headers. It's okay if you have a long one because we can break them to size just like the male ones. Use wire cutters or snips and cut in the middle of the socket. When you're done, trim away the excess with either your cutter, flush cutter, or maybe some sandpaper. When you're done, you'll have a female connector the size that you want, but at the expense of one female socket, unlike the male breakaways. Now that you've got headers of the right size, you're going to put the male again on the input side, female output, male passive, female active. And before soldering, you've got to decide your orientation, flat like this or up. If you go up like this, you get the strongest mechanical connection, but for prototyping, sometimes the flat version is really nice depending on your breadboard. So you've got to decide which orientation you're going to prefer. Now you're ready to solder. We are now going to demo soldering the vertical one, and then later we'll do the complete flat version. Ideally, we would have a clamp to fixture our components while we solder them, but maybe during COVID you don't have access to that, so electrical tape can be a nice substitute. Electrical tape stretches and remains a little elastic, so if you apply the tape while you're holding it taut, applying tension to the tape while you're applying it to an object, you'll notice it stretches, and it will actually maintain positive force on that object once you apply the tape. You can see it deformed right here. Once clamped, we're going to prep our iron. So just clean off the tip, and you'll notice there's some wad sticking to it. If that's the case, you could just tap it, and those things will pop right off. That also suggests that this iron has been sitting for a while, and there's a bunch of gunk built up on it. So first you want to clean that stuff off. One of the best ways to do it is just apply a bunch more new solder if you don't have tip cleaner, and that solder will release a bunch of flux that will clean off some of the gunk as long as you get rid of that compromised solder. So with a clean tip, you should be able to tin it a little bit and you're ready to go. The first thing we do is create a temporary tack joint on just one pin. You'll notice during this time the pins are sort of freely moving. This gives you an opportunity to get the orientation, the alignment that you want. And that alignment is going to hold all the other pins in place while we solder them. If, for example, we were doing this on a table and that first tack joint was really imperfect because the pins were out of alignment, like you can see here. So now is your chance to fix the alignment to, let's say, be perpendicular in this case. If you need tighter tolerances, you can use a breadboard as a fixture, but only for the tack and only if you apply heat for a very short amount of time. When you're done, you've got a tack joint that's holding all your pins in alignment, and you can start soldering all of the other pins and fix the tack pin last. So again, we skip the tack pin and start soldering some other pin, like the furthest one away. The tack pin is holding alignment, and as we're soldering, we don't have to worry about the other pins moving. So you just do your typical soldering, apply heat, hold heat, apply solder, remove heat. Remember to keep cleaning your tip and tinning your tip as you're doing this stuff, and very importantly, make sure you fix that tack joint. That is a compromised solder joint. It's not meant to hold well. It's going to cause you problems later on. So just go over it, apply some new fresh solder, and you should be good to go. Now we're ready to do the female side. Make sure, again, that is the output side, the active side. Here I've done a really poor tack just to get some solder on there. Now I'm going to align it. Careful not to burn yourself. Probably better if you use like a metal tool instead of a finger. And now you are ready to solder all of the connections except the tack joint. So the tack joint is holding the alignment in place. You can go through and solder up everything else. I could probably do better here by cleaning the tip in between every, I don't know, 3 or 4 times I apply solder. And very important, at the end, you fix your tack joint. You apply some more solder to clean it up. Here it looks like I got a little too much solder on that tack joint, maybe the second joint as well. So I'm going to do the add more solder, add more heat trick, and hit it on the table to just get that solder off, and then apply some new fresh solder to that tack joint. All right, now we're going to show the flat horizontal orientation. So here we're going to pre-tin the pads. It's very important though, you only use a small amount of solder. You don't want a bump to form, because then that header won't be able to lay flat. The pins of the header won't be able to lay flat on the circuit board. Once you've got everything nicely pre-tinned, we're going to go and create a tack joint on one of those pins. So first, we're just going to want to get the pin wet. It's going to move all over the place, don't worry. Just get some solder on the pad and the pin. And now you can come back and fix the alignment. Not with your finger, some other metal object like that. Now you can melt it. There's plenty of solder, and you can take your time getting the alignment just right. I don't care if it's a bad solder joint, like it looks terrible, because again, it's just a tack. I'm going to go back and clean it up later on. Now I'm ready to solder up the rest of all the other pins. As you're doing this, something that would help is to make sure you're applying some pressure to that pin, so you're getting some good thermal conduction between the tip of the iron. Unlike me, keep cleaning your tip. You can see my joints are getting worse and worse as this tip keeps getting more and more gunked up. I should be cleaning it every now and then. Very important, do not forget to redo the last tack joint. After that, you can flip it over, and here I'm fixturing this little guy to the table with some electrical tape, as discussed before. I've got a tack joint here that's really poor, and I'm going to heat up that tack joint to fix the alignment. And I'm going to use some metal object to fix the alignment on that pin that's going to be really hot. All right, if the alignment's good, the tack is holding, it's a terrible joint, I'll fix it later, but while the pins are held in alignment, I will go and solder all of the other pins. Here I've sped it up a little bit, but it's the same process. The tack pin is holding the alignment, you solder all of the other pins, and very important, at the end, make sure you fix that tack pin. You apply new fresh solder to clean it up. And your component is ready to go. So you're going to repeat this process for any other development board. You're going to get male headers on the passive side, female on the active, choose your orientation, flat or vertical, and you're done.